How computers store data. Computers are unlike humans. They need data to be arranged in organized sets or collections to work with them. Computers only store data as numbers. There are many types of programs that can be written to store, manipulate, and visualize data, and it is a constant challenge and an evolving process to make human data understandable to computers. Insight and knowledge can be obtained from translating and transforming data, and patterns in the data can emerge. Data storage on a computer is defined by a hierarchy of 4 levels: primary memory, secondary memory, tertiary storage, and offline. Let's look at primary and secondary memory. Primary memory, or primary storage, temporarily houses applications and data that is currently in use. This form of storage is typically located inside of the computer. Since this memory is located on the motherboard, it can be accessed very quickly. Primary storage or memory can be volatile or non-volatile. An example of volatile memory is RAM, random access memory. Data stored in RAM is lost as soon as the power is turned off. The more RAM a computer has, the more applications it can run simultaneously. Also, unlike other forms of memory, RAM can be upgraded easily. ROM, or read-only memory, is an example of non-volatile, permanent primary storage. ROM retains its contents even if the device loses power. An example of information held in ROM would be the boot instructions for a computer. The flash memory in a solid-state drive is another example of primary, non-volatile memory, since the data can be recovered after a power outage. Here are the differences between RAM and ROM. RAM, random access memory, is volatile. The content is read, changed, or added. Chips are expensive, bigger, and slower. Installed with large storage. It stores applications and data when the computer is running, and the processor can directly access it. ROM, or read-only memory, is non-volatile. Content is only read. The chips are cheaper, smaller, and faster. Much smaller storage capacity. It stores instructions required for starting or booting the computer, and the processor can only access after ROM is transferred to RAM. Secondary storage, also known as auxiliary storage, retains data until you either overwrite or delete it. All data remains intact even when it's turned off. Here are some common examples of secondary storage. Hard drives. They're built into computers, and it is the standard. Optical media includes CDs and DVDs. Magnetic tape is older but reliable. Secondary storage does not have direct access to the CPU, so it is slower than primary storage. However, it is also much cheaper and can hold a lot more data. While a computer might only have 8 GB of RAM, it could have a 1 TB hard drive. Storing digital information, like text, audio, or video, uses many of the same ideas as transmitting digital information. The information is stored as bits. It may be compressed and, if necessary, encrypted. The 3 most commonly used storage technologies today are compact disks, hard disk drives, and solid-state drives. Data are stored on a compact disk by burning pits with a laser in circular tracks on the metal film inside a rotating plastic disc. A CD player reads the disc by bouncing a tiny laser light off the surface, following the tracks as the disc spins. If the light is reflected, the player reads 1, and if it is not, it reads 0. The original CD was designed to store about 70 minutes of stereo music, sampled at 16 bits at a frequency of 44 kHz. Improved discs included the DVD and Blu-ray, which could store several hours of video for playback, and CDR and DVD-R, which enabled users to write and erase, as well as read. Many forms of the CD are becoming obsolete. Hard disk drives were invented in the 1950s. They started as large disks up to 20 inches in diameter, holding just a few megabytes. Hard disk drives have a spinning hard platter that is covered with a thin film containing grains of magnetic ferric oxide. Hard drives use an electromagnet to apply a magnetic field to the ferric oxide to write on the disk. The oxide remembers the field it sees until it is overwritten, even many years later. The same electromagnet can be used to read the microscopic magnetic fields written on the disk. Hard disk drives are being replaced by solid-state drives. A solid-state drive, or SSD, stores data on special computer memory chips that remember even when there's no power. SSDs have many advantages over HDDs because there's no moving mechanical components, they're much smaller and lighter, and they read and write data much faster. The USB thumb, or flash drive, is a form of SSD that can be plugged into a computer. The cloud has now become the standard for secondary storage, sometimes even primary storage, since it is safe, reliable, and available anywhere. The cloud refers to servers that are accessible through the internet. Cloud servers are located in data centers all over the world. By using the cloud, individual users do not have to actually have physical hard drives for storage. The data is physically stored somewhere, but not on the user's personal hardware. This allows for many users to simultaneously access the same files from anywhere in the world. It has truly changed the way people can use computers. Data processing occurs when data is collected and translated into usable information, like graphs, documents, charts, etc. This information can then be used by an organization to make educated decisions. There are 6 stages of data processing. Data collection, where data is collected from a variety of sources. The goal is to get the highest quality data possible from a trusted source. The second stage is data preparation, where data is cleaned and organized. Bad data is removed. The third stage, data input, where clean data is entered into a program that will be used to convert the data into usable information. Stage 4 is processing, where data that was inputted is then interpreted by a computer program. The computer might use a machine learning algorithm or a different method, depending on what type of data is being processed. Stage 5 is data output, where data is finally turned into information that can be used by non-data scientists. The outputted data will often take the form of graphs, charts, images, plain text, etc. The final stage is storage. The last step is for the information to be stored somewhere that it is accessible by the organization for use when needed. Here are some factors that may affect the speed of data transfer. In a computing system, the type of processor, the amount of RAM, the size of the file, and hardware. Across the internet, we have bandwidth, bit rate, and the number of users.